All right, so for quadratics, just like every parent function, we have our parent function points. Now, if you can't memorize points, just know that your x values go from -2 to 2. Okay, so if you struggle and you can remember that, oh, my x values go from -2 to 2, think about what is -2 squared? 4. Okay, so then it corresponds to 4. What's -1 squared? 1, and so forth. So you can always derive it that way. And then when we graph it, it's going to be symmetrical across the y-axis. That is our axis of symmetry. And you don't always have to draw it in. I will for us right now so we can see it. Okay, remember it is a vertical line, so that means that we have to give it, even though it's not part of the function, it's dashed, we have to give it a name. So we say x equals 0. All right, just like every parent function, the vertex, our hk, is going to be 0, 0. Our x-intercept for this is 0, 0. The y-intercept is 0, 0. Our domain, the domain for x squared is either all real numbers or -infinity to +infinity. Remember, to get ready for pre-calc, you need to get more comfortable with the interval notation. And then the range and domain are always listed from smallest to largest. So we're going to say that y is greater than or equal to 0, or we're going to say bracket 0 to infinity. The bracket is inclusive, whereas the parenthesis is non-inclusive. So we can't include infinity. We'd like to say we have an infinite amount of chocolate chip cookies, right? If that's something that we love. But unfortunately, you can't have it. All right. Increasing and decreasing. If we were to travel from left to right on the graph, our graph is going down, and at the vertex, our graph goes up. So we say that and we always discuss it with the domain elements, we say that we increase from 0 to infinity, but we decrease from -infinity to 0. It's always the domain elements because we're saying from what x value to what x value do our y values increase? Well, they increase when x goes from 0 to infinity. And we never use a bracket because at 0, it's changing direction. It's not inclusive from one to the other. All right, 1 to 1, yes, it passes both the horizontal and the vertical line test. In other words, there's 1x for every y corresponding to every y, and then there's 1 y that corresponds to 1 and only 1x. Rate of change is exponential, it varies. Axis of symmetry is x equals 0, it's that vertical line, so it's always x equals. This does have a minimum or a maximum. That's always going to be your y value, or in this case, the k of our vertex. And then we don't know about asymptotes yet, so we're going to put NA. So, ladies and gentlemen, whoa, there is the parent function for your quadratic function. Yay! Okay, let's get to the good stuff. All right. Keep in mind, let me get my black real quick, that you could also have the B value. Okay, B is your horizontal stretch or compression. Okay, so looking at this example, we don't have a B value. Okay, we know that A is 2, which means that there's a vertical stretch. You have to get comfortable with that verbiage, that language. B is 1, so there isn't a horizontal stretch or compression. We're going to say that H is 5. We always take the opposite sign for the H, so we move 5 units right. And then we're going to say that K is -4, so we move 4 units down. Sweet. Okay, so we know what they are, we know what they do. Just a friendly reminder, the reciprocal of B is multiplied to X, and then we either add or subtract H depending on what our H value is. And then the A is multiplied to the Y, and we add or subtract the K value. Okay, this is how we transform the parent function points so that we can preserve the shape of the function. That isn't going to change. We're going to follow that every single function, which is really nice, because if you can get comfortable with remembering all of that, then when you're graphing the function, the only thing that's going to change, well, yes, is the function shape, but the points, all the transformation effects stay the same. Okay, so here we go. So B is 1, so we're just going to put X plus 5, and then Now you guys can see your parent function points, but I can't. So I'm just going to write them next to my table so that I can pull the numbers that I need. And we're going to plug them in. So -2 plus 5 gives us 3. -1 plus 5 gives us 4. 0 plus 5 is 5. 1 plus 5 is 6. And 2 plus 5 is 7. Okay, now take the y values. 4 times 2 is 8. Minus 4 is 4. 1 times 2 is 2. Minus 4 is -2. And then we get -4. And then we should repeat, because it is a symmetrical function, across a vertical line. Graph it with me, please. So 1, 2, 3, 1, 2, 3, 4. And then 4, -2, 5, -4, and it reflects. There isn't a vertical reflection, so it makes sense that this should open up. Remember, the a value determines whether it opens up or down. Is there a negative in front of the a, or is there not? Okay, you can, if you would like, draw the axis of symmetry. It's not required, but we do know that the vertex is HK. So our vertex is 5, -4. The x-intercepts, ooh, do we know what those are? No, we do not. So we get to solve for them. So exciting. Okay, plug in 0 for what? If I'm solving for x, wait for it. Yes, plug it in for y. And we have 2 times the quantity of x minus 5 squared minus 4. Let's start solving. Our goal is to isolate the x. So I'm going to add 4 to both sides. Equal to 2 times the quantity x minus 5 squared. And then divide by 2. So we get x minus 5 squared is equal to 2. Take the square root. Now remember, when you take the square root of a number, you have the positive and the negative. We don't know which one we're solving for. Okay, we're choosing to take the square root. So that means that we have to account for both possibilities. So x is going to be 5 plus and minus the square root of 2. Sweet. And we'll just leave it like that. We'll write it as a coordinate because it is a point. So 5 plus and minus rad 2, 0. All right, y-intercept. Do we know it? No, we do not. So the y-intercept, we're going to do the opposite. Algebraically, we're going to plug 0 in for x. And we're going to simplify down. So order of operations, we'll do what's inside the parentheses. So 0 minus 5 gives us that -5. Exponent means we'll square it. So we have 25. And then 2 times 25 is 50 minus 4 gives us 46. Whew, aren't we glad we're not graphing that one? So we have 0, 46. Okay, so now we've found not only the vertex, but our x and y intercepts because we know they exist. We can see them. The domain, again, is going to be all real numbers or -infinity to +infinity. The range, since it opens up, it's going to be greater than or equal to the k value. Or we're going to say from -4 to infinity. Increasing versus decreasing. Well, our graph opens up. It goes from left to right. It starts decreasing first. So using our x values, we're going to say from -infinity to 5 is when it decreases. And then at 5, it switches to increasing. We use the x values to talk about whether our y values are increasing or decreasing. Is it 1 to 1? Yes. The rate of change varies. Our axis of symmetry, looking at it, ooh, x equals 5. It is always the h value. Minimum value is -4. There isn't a maximum because this opens up. And then there isn't a horizontal, nor is there a vertical asymptote. Excellent. All right, guys, one more. Very exciting. Haha. What does this one have? That's right. It has our b value. So don't forget, please, you always have to factor out the b value first. So -2 times the quantity of 1/3. When we factor it out, you're taking 1 and dividing it by 1/3. So that means you're going to multiply it by the reciprocal. Quantity squared plus 5. All right. So a is -2, which means that you have a negative times the 2. Oh my gosh, sorry. Okay, so there's two things happening here. Not only are we going to have that vertical reflection because of the -1, but we're going to have a vertical stretch. So we're going to see a parabola that opens down this time. and a vertical stretch. Okay, the b in the equation is 1/3, which means it'll be 3 in the transformation table, which means it's going to be a horizontal stretch. All right, our h is a -3, so we're going to go 3 units left. And our k is a 5, so we're going to go 5 units up. All right, here we go. In the transformation chart, we're going to have 3. We take the reciprocal of b times x minus 3. And then a, which is -2y plus 5. Our points are -2, 4. These are from the parent function. Remember, we are trying to preserve the shape of the parent function graph. Okay, so if I take -2 and plug it in for x, I get -6 minus 3 is -9. -1, that means -3 minus 3 is -6. Plug in 0 for x, you get -3. Plug in 1, we get 0. Keep going with me, 2, you get 3. All right. If we take our y values and we have 4, take 4 and substitute it in for y, you get -8 plus 5, -3. 1 will get -2 plus 5 is +3. Plug in 0, you get 5. Plug in 1 again, you get 3. And then plug in 4, you get -3. All right, graph it with me, please. So -9 and then -3. Oh gosh, let me make that bigger. There we go. And then -6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. And then -3, 5. And we can reflect from there. Again, if you want to draw the axis of symmetry, you can, but you are not required. Okay, our vertex is HK. We wrote it when we were writing the transformation, so we get -3, 5. Our x-intercepts exist, but we don't know what they are, so we get to solve, just like we did in the previous example. Let's go ahead and plug in 0 for y. Sorry for all the changes in the size, guys. So 0 is equal to -2. You can use the factored out version or the given. It doesn't matter because you're solving for x. You'll get the same answer. So I'm going to subtract 5. I get -5 is equal to -2 times the quantity of 1/3 x plus 1 quantity squared. And then divide by 2, -2. So we get the quantity of 1/3 x plus 1 squared is equal to 5/2. Take the square root, so we get 1/3 x plus 1 is equal to plus and minus the square root of 5/2. Okay, but we have to rationalize. So if I have the square root of 5 over the square root of 2, I have to get the radical out of the denominator. So I'm going to multiply the top and the bottom by rad 2. That leaves us with rad 10 all over 2. Okay, so 1/3 x plus 1 is equal to plus and minus the square root of 10 all over 2. All right, subtract 1, we're almost done. So 1/3 x is equal to -1 plus and minus the square root of rad 10 over 2. And I'm going to multiply everything by 3. So x is equal to 3 times this quantity that we've already found. Or if you want, you can distribute. So it could be -3 plus and minus 3 rad 10 all over 2. Okay? Yay! But we're not done because we have to write it as a coordinate. I'm going to choose to distribute the 3. That's my personal preference. Whew, good stuff, guys. And then is there a y-intercept? Yes, yes, and it's in the chart. You're so happy right now. Okay, domain, again, all real numbers or -infinity to positive. The range goes from either the minimum up or the -infinity to the maximum. That's where we're at right now. So y is less than or equal to 5. Or we're going to say from -infinity to 5 inclusive with a bracket. Okay, always go from smallest to largest. Now, since this is opening down, it's concave down, it has a vertical reflection, our graph is going to increase first. So we say from -infinity to -3, and then from -3 to infinity, it's decreasing. we address are our y values increasing or decreasing in relation to x? Okay, so that's why we use our x values. Yes, it is 1-to-1, varies for our rate of change. The axis of symmetry is always the h value, so x equals -3. Please, 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 please don't forget the x equals. It is a dashed line. Okay, it exists. We need to make sure that we have the equation. There isn't a minimum value because we do have that vertical reflection. The maximum is 5, and we don't know the asymptotes. Whew, you made it. Congrats. That was awesome. So there's 3 examples for you, one of them being the parent function for our quadratic functions.